Okay, we are back for lecture 2.2 and part 2 of the periodic table. All right, so here was the table that we started with in the first part. We see some color coding based on groups here. Here's a copy of the periodic table from the inside cover of your textbook, which has different color coding, right? That there are multiple ways to visualize the periodic table by changing the colors of things, sorting it into different ways based on how you look at it. Even if the elements are in the same place, this one looks different. Sometimes we also see the periodic table color coded based on state, so solid, liquid, or gas. In this one here, we see the color coding is based on metal, nonmetal, and metalloid. So right away you can see most of the periodic table, meaning most of the elements that exist as what kind of element? Metals, right? Most of the table here is blue. It's also clearly, other than this oddball hydrogen, the left-hand side are all metals, and the right-hand side are non-metals, okay? And then where they meet in the middle is something else, something not quite metal, not quite non-metal. These are called metalloids. Okay, so here, oops, here we're going to talk about the physical property differences of metals and nonmetals. Right, so the majority of elements that exist as what we would call a metal. What that means is that they are shiny if polished. They can get rusted if they react with oxygen to make oxides, but generally they're shiny. They are all solids, except for there's one exception, which is mercury, which is a liquid, sometimes called quicksilver. It's naturally a liquid metal at room temperature. They all conduct electricity and they are actually flexible. Now, nonmetals off here to the right are dull in comparison to the metals. They can exist as solids, liquids, or gases at room temperature. Remember this column, 8A, what are they called? They're called the noble gases, right? Because they are gases at room temperature. Nonmetals are poor conductors of electricity, and when they are solid, they are brittle and hard or soft. Okay, so there can be some differences there. And notice the gray kind of stair step down the middle. On either side of it, it's not exactly perfect, but mostly through the middle on either side are the metalloids, right? And so they have properties somewhere in between the metals and the nonmetals. All right, this is really a short section. This is going to be a short lecture. The last subsection is about elements that are important in biochemistry and medicine. Right? There are a lot of elements on the periodic table, a lot of elements that exist that would be toxic to biochemistry, to our bodies. There are some elements that are absolutely essential to biochemistry. And you can kind of see where they fall in the table. Again, representing things a little bit differently by different colors draws your attention to where things are. So there's kind of three main types that we're going to look at. One is the building block elements. So these combine to form the compounds in living organisms. So the ones that our bodies are made up of. These are also ones that will show up most often in organic chemistry. right? Compounds that are made from hydrogen, carbon, nitrogen, oxygen, phosphorus, and sulfur. So they're elements in the top of the periodic table, few protons, small as well. But these are the ones that basically build up everything in all compounds in our bodies. Next are nutrients. So these are required for functioning, and you can see here in the figure where they appear in different structures and organs in our body. So macronutrients in orange here are required greater than 100 milligrams a day. So these would come through your diet. Nowadays, if you're not getting enough in your diet, you can get them through supplements for multivitamins and nutrients. So we see a cluster here in the metals, alkali and alkaline earth metals, sodium, magnesium, potassium, and calcium, as well as phosphorus, sulfur again, and chlorine. The remaining elements in yellow here are micronutrients, right? That require less than 100 milligrams a day, but still important. Many of these metals would be things that you may be getting in your multivitamin. Okay, I'm not going to read them all again, but we see that we have a series of metals in the transition metals, and then some non-metals over here. And here's where the figure shows where these are being used and how they're being used in different organs and parts of the body. So this figure of the guy is actually from the beginning of the chapter. There's an introductory section about micronutrients and nutrition that is worth a read, so you can check that out. How many protons and electrons do the following elements contain? So this is kind of a review back to the last section, but looking at each of these types of elements that are important to biochemistry. So number one, oxygen. It's a building block element. How many protons and electrons do the atoms of oxygen contain? Okay, well, how do you know that? Well, remember that the 8 above oxygen is the atomic number, and the atomic number is equal to number of protons. Proton has a plus charge, so sometimes we can abbreviate it as P with plus. How many electrons? Well, atoms, as they generally exist, are neutral. Unless if something has happened to it, we can create ions, but in general we think of them as neutral, so the number of protons, the number of electrons have to be equal. Electrons have a negative charge, so we often write it as E minus. Chromium is a micronutrient found here in the transition metals. It's element number 24, so we know it has 24 protons. It's neutral, so it has 24 electrons. Phosphorus, element number 15, so right away we know it has 15 protons. If it's neutral, how many electrons does it have? Also 15. You get the pattern here. Okay, a couple review questions and then we will be done. Which group is called the alkaline earth metals? Maybe I shouldn't have used this figure. There we go, right? 2A. You don't really have to memorize these group names, but if we use them, it'd be good to know. You need to know what we're referring to, and if you don't have to look it up, it saves you time. So having these, there's only 4 of them, so having these 4 memorized would be good. Okay, next question. To which periodic group does iron belong? Element symbol Fe. So remember that not all the symbols don't always make sense with the English name because these elements weren't all discovered by English-speaking people, and not the names aren't the same in all different languages. So often we'll find some of the older elements with different symbols, like Fe for iron, um, which is why it's helpful that a table has both the names and the symbols. So have you found it yet? It's right here, right? And so it's not one of the main groups, so it doesn't have a special name. It's just part of the transition metals. Okay. Select the false statement concerning metals, which is not true. I'll let you answer this for yourself. So pause it as you read them. Okay, do you have an answer now? This one is wrong, right? So meaning that's the correct answer. There are a lot of metals on the periodic table. In fact, the majority of the table is metals. All the rest of these are true. Metals are shiny, conduct electricity, solid at room temperature, and flexible. Okay, identify the element in period 4, group 7a. Periods are not numbered here, but starting with hydrogen, 1, 2, 3, 4, 7a, they meet right there. So Br, well, which one is Br? Is it bromine, boron, or barium? You might need to look this up on a different table that had the names as well, and you would find it is bromine. So there are a lot of similarities like this in the names. So bromine is Br, boron is just simply B, and barium is Ba. They are here and here. Okay, so that's it for this lecture. Like I said, it's a fairly short section, but we'll keep it here for now. So check out the post-lecture questions for lecture 2.2 and read the section in the textbook. And then we'll come back next time for lecture 2.3.